This is the chart of the gears that I have prepared just to show the ratios. The top part of this chart, which is this section here, is all the Imperial gears, and it's a little difficult to see because of the size of the text, but there's quite a lot of gear ratios possible. The main headstock gear, compound large, compound small, driven wheel, what TPI lead screw I've got, then there's a calculation, and then the threads per inch that it gives. And the headstock gears are depends on what pitch I want. The very coarse pitches require 80 teeth on the headstock gear, and as it gets slightly less coarse it's 60, and then when you get to the much smaller threads you're down to 40 teeth on the wheel. The compound gear up to this point here, that whole section, you only use the one gear, so it's not compound, in fact it's just one gear of 136 teeth, and it's not compounded with the second gear. If you're cutting very fine gears, then there's the 68 tooth compound gear on the wheel, which I'll show you in a moment. Then the driven wheel is a selection of sizes depending on the ratio of the headstock gear, and in general terms, the smaller the number, the coarser the thread it will cut, and the larger the number, the finer the thread it will cut. So you'll see here that I've got 10 threads per inch, 12, 14, 16, 18, 20, 22, 24, 28, 30, 40, 41. I've got some odd sizes here which are just made up out of the gears that come from the metric set. So if I go down the spreadsheet to the bottom here, these are the metric gear ratios, and that has a transposition gear of 127 teeth. The headstock gears are the same, 80, 60 and 40. So I only need 3 different gears on the headstock. The compound runs on, as the Imperial side does, the 127 with no compounding gear on, just straight through, simple gearing ratio. The driven wheels on the lead screw range from 51 that's 51 on 80 tooth headstock gear, 51 on 60 and 51 on 40. So you can see we reutilise gears on different sets of headstock gear ratios, which is quite handy because it reduces the number of gears that are required. But the net result of all that is that I've got metric pitches of 1.7, that's 1.73, it's close to 1.75, 1.5, 1.24, again close to 1.25, 1 exactly, 0.8, 0.7, 0.5, 0.4 and 0.25. So a very useful set of ratios, and really produces almost every gear I think I could want to cut. If you've got anything particularly fine and unusual, you could easily cut 1 extra gear. They're relatively simple to cut and can be cut on this lathe. Now we'll take a look at the gears themselves. These are the gear wheels, some of which I've cut. Now I'll go through these in turn. This little stack here are the headstock gears. This is the 40 tooth headstock gear that came with the lathe when I bought it. This is one I cut in EN9, which was perhaps a bit unnecessary, but it's nice and tough, it'll never wear out. This one I cut in 7075, and you can see I've got keyways which I glued in with araldite just to be sure that they didn't get lost or drop out when I was changing gears. The gear that mates with the headstock gear are the change wheel gears, and probably you can see that, and 136/68, so it's 68 on the back, and they're just simply screwed together, these, and they sit on a pivot which goes down the arm. I'll show you that in a second. So I had to make up an interposing translating set of gears for the metric set, which are 127 tooth, and on the back of the 127 I had the luxury of being able to change from a compound gear of 75 tooth or 50 tooth, and I could have made a 25, and that's the 50 tooth gear. That's quite a handy thing to have. Then the next gear, which is worth just talking through, is this gear. Now this is a gear that allows you to put the gear train into reverse, and it's just added just before the lead screw, and I've made several different sizes. The one that came with it was 30 tooth. I made a 50 and a 75. This slides down the arm of the gear quadrant, and they don't affect the ratio of the gears, they just affect the direction that they run in. So the moment you fit this gear in the train, it throws it into reverse, which is really handy. So all the gears that I've shown on the chart earlier can all be cut for left hand or right hand. Then this stack of gears are the ones that I've spent most of my time making, and they fit on the lead screw. They've all got 2 holes in them, and they fit on simply by screwing on. They don't have any, they don't require anything special, they don't need any bronze inserts or anything, so they're just straight gears, and they're all cut in 7075. So these particular ones start, I haven't put the 41 here, but that's 41, 42, 43, 44, I've stamped them all so they don't get muddled up, 46, 48, 50, and no, I've got a 51, that's a 52, 54, 56, 60, and that's one where I'm just running out of material, 64. And the one that came with the lathe originally was an 80, which gives very fine threads. So those are all the gear teeth that I've cut and I've got with the lathe now. And I think the next thing to do is to show you the quadrant arm and how that works. So I'll move these out of the way. And out over here. This is the gear quadrant. Very simple. Consists of a threaded rod that goes to a block that fastens onto the slide, and then there's a bearing at the end there. Very simple arrangement. Bolts to the lathe on that section, and then this dovetailed slide is what contains the gears. And I've got the extra gear that I can load into here, and it goes in between that one, and that would reverse the gear ratio, so it gives you left hand threads. If I want to cut using the transposition gears, I can turn this round so that that then mates with that, and this mates with the headstock. So I think the thing to do now is I'll show you the lathe before we fit it, and then the work that's involved in fitting this arm, which is not very much work to do. I'll do that next. I'll start off with the cross slide, with the compound slide fitted, and I'll take it off and replace it with the one that operates the gear ratio, the thread cutting. I've now set up as if doing some turning operation on the end here, and having reached the point where I want to then thread it, it's very simple to take this off. You need to unclamp the screw at the bottom and slide that off and put it out of the way. Take the screw off the bottom, take that out of the way. And the next thing to do is to put the slide on that's used with the thread cutting. That's a self-contained arrangement. Just pop that on there loosely for the moment, and then the gear change wheels themselves. I've set this up without using the transposition gear, but using the 125 onto 51 teeth and 40 on the headstock, and this is the setting for 1 millimeter metric pitch. So all you have to do is to roughly line it up here so that the headstock gear and the 125 tooth gear are in alignment, and then tighten up these 2 nuts on this little slide here. On the bottom of this section, this plate here has to bolt into the, that's in the right position now. That getting in the way so you can see what's happening. And that's now moving as the gears move. And this clamp affects the mating with the gear on the headstock. So if I just make that a fit that's not too tight, not too loose. Alright, so that's that. And then I'm going to be turning this with the screw handle. This I bought off eBay a little while ago, very neat little arrangement, and that's how you cut gears. Just pop the tool post on. So that's not a difficult job to do, and then you just turn this in to the point where you want to cut your threads. Tighten that up first. cutting a metric pitch of 1mm. I won't go on to produce the whole thread, but it'll give you an idea of what happens. And then if I get my thread gauge, I can check that that's indeed the cut that I wanted to take in the first place. That's 1.0, and yes, that is exactly 1.0. So that's very simple. Now if I want to cut a reverse thread, I'll change over and show you how that works. All we have to do is loosen the screw here. Take that wheel off. Put the reversing gear in. It's the reversing gear. Run down here and put the reverse pitch on. And you can see it's cutting away from this direction from the chuck. So if I move the camera now and put it on top, you can see that that's cut two different directions. It's on a metric pitch gauge. And you can see that this thread here is angled in that direction, and this thread is angled in that direction, so it's that way and that way. I'm now set up to cut half a millimetre thread, and you'll see that this gear, I put a 60 tooth on here, the 75 on here, and the 127 on here, and the 40 on here, and in this position where it was before it's lined up incorrectly, so I've seconded these off and we move this back until the main large wheel mates with that, which it does now. Tighten that up. Tighten that up. So that enables us to cut half a millimetre thread. So we just turn that over to there so we can see what's happening. I could be running this under power, but I prefer to use it by hand. I like this arrangement. Right, I'll cut the thread now. So that's cut 1/2 millimetre thread. Just take a close-up look. So as you can see, it is easy to use, a simple arrangement for what appears to be a very basic lathe, but actually it will do quite a bit. It will cut gears, it'll cut gear teeth, it'll do ordinary turning. Quite handy, and really good enough to use for clockmaking, that's for certain. So that's the little exposition on how to use the thread cutting attachment, which is now working well both in metric and imperial. I set up to cut a 1mm thread with 51 tooth wheel on the driven, 40 on the lead screw, on the head screw, and 125 between them. I'll just put this back up and we can cut it. Now the screw I'm going to be cutting is M6, which is a 1mm pitch thread, and what I'll do is I'll cut it until I can fit the nut on, just to prove to you that it's a 1mm pitch. There we go. So you can see that it's actually quite a nice fit on there. And also you could see that I was a bit unsure quite how much of a depth of cut to take at any one turn, but I got the hang of that quite quickly. That's the first thread I've actually cut to fit anything, so yeah. That's absolutely perfect. So that shows cutting an actual thread and making sure it fits.